So hey guys, welcome you all to my YouTube channel. So today we are going to learn about statistical machine learning. So today's topics are types of learning. So the first one is supervised learning and the other is unsupervised learning. So let's continue. So guys, what are the types of learning? In these types of learning, I have derived it in two classes, which is supervised learning and unsupervised learning. Then there are two categories. One is discrete category and one is continuous category. In supervised learning, discrete category comes classification or categorization, whereas in continuous category, it comes regression in supervised learning. And in unsupervised learning, in discrete category, there is clustering, and in unsupervised learning, the continuous category have dimensionality reduction. So I'll be telling you this further in the video, so stay tuned to learn all about these things. So how does the machine learning framework works? So first of all, let's see how the framework works. So when we apply a prediction function to a feature representation of the image to get the desired output, let us take an example that we consider an image as an input, and we have to check it as the output. If we consider the image as an input for an apple, so we will see if it is true, so it will be processed by the function, and if it is true, then the machine learning will provide you that yes, this is the true thing. So in this function, in example I have shown you the images of like there is an apple, there's tomato, and there's cow. So further I'll be telling you more about the examples, how is the training done and how is the testing done. So y is equal to fx. This is the formula where y is the output, y is your desired output, and f is the prediction function, and x is the image feature. So the image feature, or the image you want to test, or the image for which you are going through the training, will be processed by the function, prediction function, and y will be the output. So what is training? Given a training set of labeled examples like x1, y1, x2, y2, and goes on like till xn, yn. It estimates the prediction function f by minimizing the prediction error on the training set. Testing. So for testing, we apply the function to a never before seen test example x, and the output, the predicted value will be y is equal to fx. So y will be the output, and during training we will be taking lots of images during the training, and during the testing we will be testing in another image which won't be done in the training. That's why it's told there that never before seen test. So further going on, so training images. Now we will be seeing the steps that how this framework works. So in training images, we have taken a lot of images, like for apple, for many fruits like apple, guava, and pineapple, and everything. For vegetables, we have taken the input as tomato, and the for animals we have taken input as many animal pictures. So how does the model works? Further, from the training images, we feature the image is featured in this training images, then the function is applied on them, then training labels are applied where we can see the training is done, then we have the model learned here. The model of training will be learned, and that's how further it will work in testing. During testing we will be taking an image of apple which you want to be which you did not have taken before, then it will be the test image, and by the image will be featured, then the it will go through the learn model process, and then the prediction will be made by the machine. So what is classification? Now, as I have told you before in the second slide, that what is classification, it is the part of supervised learning and discrete category. So classification is the process of finding or discovering a model or function which helps in separating the data into multiple categories, classes, discrete values. For example, discrete values. In classification, data is categorized under different labels according to some parameters given in input, and then the labels are predicted for the data. In classification problems, a learning algorithm learns a function to map inputs to outputs where the output value is a discrete class label, for example, cat or dog, malignant or benign, spam or non-spam email. So if you are for example, I'll be telling you what is classification if I explain you. So there are mails, there are email. So the email have the category of spam and non-spam. So first is the junk, uh, you can see in your inbox, so that is non-spam. And you have one spam box in your email. So this is done by the classification, this is done by the machine learning. So now, what are the popular classifiers? What are the popular classifying theorems we can see? So first is naive Bayes, then K nearest neighbor, then SVM, randomized forests, Bayesian network, logistic regression, boosted decision trees, RBMs, and neural networks. So what is classification for? I have told you. Now we will see the example. So the first example is credit scoring. So differentiating between low risk and high risk customers from their income and savings. This is done by the classification. So classification will be take a set as an input, then it will provide you outcome that it belongs to which set. So you have to provide some conditions. From that conditions, it will tell you that which input goes in which state. Okay, goes in which set. You have to give in set as an input, then it will tell you that which one belongs to which spam or non-spam, in case of emails, or low risk or high risk in case of this example credit scoring. So now here you can see the graph. So if income is greater than the theta 1, and theta 1 you can see on the income line as the x-axis, and high risk, or sorry, the savings on the y-axis, theta 2 you can see there. So discriminant is if the income is greater than the theta 1 and the savings are greater than the theta 2, then it is low risk, because credit scoring will be low, so the loan can be paid easily. And when the else, or if anything is low or the savings are high, uh, you know if this condition does not satisfies, so the conditional operator will tell that okay, this is high risk. So this is the use of classification here in machine learning. So now coming on to the applications of classification. So first one is pattern recognition, used in the most of devices we use nowadays. The second one is face recognition, pose, lightning, occlusion, glasses or beard, makeup, and hairstyle. So now face recognition, as we use nowadays, most of the devices have the face recognition unlock thing. So when you show your face, the phone or the tablet will be unlocked, and now even it's coming in the laptops, new launch laptops. So the other is character recognition. In this different handwriting styles, you can recognize the character which is A, which is B, and like alphabets like this. Then this is speech recognition, temporal dependency, use of a dictionary or the syntax of the language, like in Java or Python, the syntax are like semicolon or anything. Then sensor fusion, there is combined multiple modalities, example visual, lip image, and acoustic for speech. Medical diagnosis, from symptoms to illness. Web advertising, predict if a user clicks on the ad on the internet. So web advertising is used vastly for the companies to advertise their product according to the user's interest. So you can see in the most of the internet browsers or browsing things, on YouTube you can see that or what that the ads displayed are according to your interest. So now coming on supervised continuous class, or so there is regression. So what is regression? So basically regression is the process of finding a model or function for distinguishing the data into continuous real values instead of using classes or discrete values. So basically it can also identify the distribution movement depending on the historical data, because a regression predictive model predicts a quantity. Therefore, the skill of the model must be reported as an error in those predictions. Regression problems are concerned with the mapping inputs to output, where the output is a continuous real number. The price, for example, the price of a house. In regression, the output will be a real number, a continuous real number. So we all know what are the real numbers. So the output, when the output is a real number, so you can assume that the process used is the regression process. So now coming on further, what are the popular regression models. So first is linear regression, coming on ridge regression, lasso regression, neural network regression, decision tree. So now coming on popular regression models. So some algorithms are either exclusively for regression style problems such as linear regression models, and some algorithms are exclusively for classification tasks such as logistic regression. So now we know in linear regression there are for regression style problems, and logistic regression are for classification problems. Okay. However, there are some algorithms that can overlap once small modifications are made of to them, such as decision trees, random forest, XGBoost, and neural networks. So in unsupervised discrete category comes clustering. So now what is clustering? Clustering is the task of dividing the population or data points into a number of groups such that data points in the same group are more similar to the other data points in the same group and dissimilar to the data points in other group. So I know you did not understand this. So basically it is a collection of objects on the basis of similarity and dissimilarity between them. I know this is easy, that's why I will tell you to learn this line, that it is basically a collection of objects on the basis of similarity and dissimilarity between them. This is clustering. Now coming on, what are the properties of clustering? Clustering is very much important as it determines the intrinsic grouping among the unlabeled data present. There are no criteria for a good clustering. So there will be a data which will be unlabeled. So now we will use the clustering process. This is the important key point here, that the clustering will be identifying the similarities and dissimilarities between them. Then it depends on the user what is the criteria they may use for satisfying their need. For instance, we could be interested in finding representatives for homogeneous group data reduction, in finding natural clusters and describe their unknown properties, natural data types, in finding useful and suitable groupings, useful data classes, or in finding unusual data objects, outlier detection. So basically, this is the thing. Now, what clustering do? This algorithm must make some assumption which continues which constitute the similarity of points, and each assumption make different and equally valid clusters. So there will be clusters and there will be different assumptions. Now the similarity of point and the each assumption, every assumption will make different but equally valid clusters. So now, what are the popular clustering method? First one is density based method, then hierarchical based methods, partitioning methods, grid based methods. Now coming on to more one. Now coming on affinity propagation, agglomerative clustering, BIRCH, DB scan, k-means, mini-batch k-means, mean shift, optics, spectral clustering, mixture of Gaussians. Now coming on unsupervised continuous category, there is dimensionality reduction. Now what is dimensionality reduction? When dealing with high dimensional data, when there is so much data, it is often useful to reduce the dimensionality by projecting the data to a lower dimensional subspace which captures the essence of the data. This is called dimensionality reduction. So as we can see, this is made up of two words, dimensional and reduction. So the set will be reduced but with the essence of the data. So the main data will be there but it will be reduced. Techniques of dimensionality reduction are principal component analysis, which is known as PCA, then linear discriminant analysis, which is known as LDA, generalized discriminant analysis, which is known as GDA. Now, what are the parametric methods? The basic idea behind the parametric method is that there is a set of fixed parameters that used to determine a probability model that is used in machine learning as well. So probability have a very much important place in the machine learning. So parametric methods are those methods for which we priori knows that the population is normal, or if not, then we can easily approximate it using a normal distribution, which is possible by invoking the central limit theorem. Now, what is the central limit theorem? I will be discussing it later. Now coming on to normal distributions. The parameter for using the normal distribution is mean and standard deviation. Now, what is mean? As we all know, I guess you have studied it in 12th. The mean, also known as average, is obtained by dividing the sum of observed values by the number of observation n. Although data points fall above, below, or on the mean, it can be considered a good estimate for predicting subsequent data points. Now, what is the standard deviation? Now let me recall you, or let me do a quick revision for you. The standard deviation gives us an idea of how close the entire set of data is to the average value. Data sets with a small standard deviation have tightly grouped precise data. Data sets with large standard deviation have data spread out over a wide range of values. Now this is standard deviation. Now, as a confidence interval in statistics refers to the probability that a population parameter will fall between a set of values for a certain proportion of time. A range of values so defined that there is a specified probability that the value of parameters lies within it. For example, you survey 100 Indians and 100 Americans about their television watching habits and find that both of the groups watch an average of 35 hours of television per week. So this is the average that you have considered it for both Indians and Americans, 100 Indians, 100 Americans. Then you have to come in conclusion that on an average 35 hours of the television viewers watch television for 35 hours per week. So however, the Indian people surveys had a wide variation in the numbers of hours watched, while the Americans all watched similar amounts. Now let me see. One Indian in 100 have watched it for just for 2 hours per week, for a work or something. But one have watched in a house, one have stayed in house and watched it for, you know, uh, 50 hours. Let's take 50 hours. Whereas in Americans there is something 35, 34, 36, 37, and like this they comes they don't have very variation. They have similar amounts. Now, even though both groups have the same point estimate average numbers of hour watched, the Indian estimate will have a wider confidence interval than the American estimate because there's more variance in the data of the Indians. That is the perfect example for the confidence interval. So this is the graph, like hours watched in the x-axis. The mean is on 35 hours and this is the number of observation on the y-axis. Now eventually the classification of a method to be parametric is completely depends on the pre-assumptions that are made about a population. There are many parametric methods available. Some of them are confidence interval. Now I told you the example for confidence interval. It is used for population mean along with the known as standard deviation. The confidence interval is used for population means along with the unknown standard deviation. So these are two different parts of parametric methods. So the confidence interval for population variance, the confidence interval for difference of two mean with unknown standard deviation. Now one is one mean with known standard deviation, other is one mean but unknown standard deviation, third is population variance, and fourth is two means and unknown standard deviation. Now what are the non-parametric methods? In non-parametric methods, there is no need to make any pre-assumption of parameters for the given population or the population we are studying. In fact, the method do not depend on the population. Here, there is no fixed set of parameters are available. So, there is no distribution, for example normal distribution etc., of any kind in available is available for the use. This is also the reason that non-parametric method are also referred to as distribution free methods. So non-parametric method is distribution free method because basically it does not depend on any kind of population. Okay, so nowadays non-parametric methods are gaining more popularity and impact of influence. Some reason behind the famous. The main reason is that there's no need to be mannered while using non-parametric methods. So there's some mistake in this PPT. Okay. So the second important reason is that we do not need to make more and more assumption about the population given or taken on which we are working on. So we don't have to make any pre-assumption for the population. Most of the non-parametric methods available are very easy to apply and to understand also. So the complexity is low considering or comparing to the parametric methods. Now, there are many non-parametric methods are available today, but let us discuss for some of them. So some of them are Spearman correlation test, sign test for population means, U test for two independent means, bootstrapping techniques, parametric. Now, what is parametric versus no? Now there's a question for you. So face recognition test. So this is the training example of a person. Then the images are shown below. Now the test images are shown below. Now tell me in the comments that which will be which process or which discrete or continuous process or supervised or unsupervised process will be used here for the machine learning, for statistical machine learning. Now tell me in the comments which will be used here and I'll pin the right comment. Now coming on to standard statistical distribution. So let us talk about normal distribution first. So what is normal distribution? A sample of data will form a distribution. Now first there will be distribution formed by the sample of data. Then by far the most well-known distribution, by far the most well distribution is the Gaussian distribution, as we all know. So this is normally called the normal distribution. So the distribution provides a parameterized mathematical function that can be used to calculate the probability for any individual observation from the sample space. Now coming on to the probability density function. What is the probability density function? So this distribution describes the regrouping or the density of the observation. It is called the probability density function. Now, what is a cumulative density function? We can also calculate the likelihood of an observation having a value equal to or lesser than a given value. So there will be a given value. So when the value is equal or lesser than the given value, the summary of these relationship between the observation recorded, so the summary of this relationship will be called cumulative density function. So what are the examples? Normal distribution, the binomial distribution, the Poisson distribution, and the uniform distribution. So now the probability density function, PDF, can be used to calculate the likelihood of a given observation in a distribution. It can also be used to summarize the likelihood of observation across the distribution's sample space. Plots of the PDF show the familiar shape of a distribution, such as the bell curve for the Gaussian distribution. So what is this? Now coming on to CDF, cumulative density function. CDF is a different way of thinking about the likelihood of observed value. Rather than calculating the likelihood of a given observation with the PDF, the CDF calculates the cumulative likelihood for the observation and all prior observation in the sample space. So basically, it allows you to quickly understand and comment on how much of the distribution lies before and after a given value. A CDF is often plotted from a curve from 0 to 1 from the distribution. So this is CDF and PDF. Now coming on to graph. So in this graph, the red line shows the PDF and the blue line shows the CDF. So now this is the graph of standard normal distribution, and in the previous slides I have told you about PDF and CDF. So now in the curve you can see the CDF curve is like this, elevating above, and the the PDF curve is like the sine wave. Not exactly like the sine wave, but it is like the this. Okay. Now coming on to the normal distribution. Normal distribution describes continuous data which have a symmetric distribution with a characteristic bell shape. It is often the case with medical data that the histogram of continuous variable obtained from a single measurement on the different objects will have a characteristic bell-shaped distribution known as normal distribution. So for an example, the histogram of the birth weight in kilogram of the 3,226 newborn babies shown in the figure 1. Now I'll show you the figure. Then for another example, you can use for normal distributions are heights of people, measurement errors, blood pressure, Pantone test, IQ scores, salaries. So these are real numbers. So for this birth weight kilogram, I told you in the previous slide about the graph. So this is the graph. In the y-axis, we are measuring the frequency, and on the x-axis, we are measuring the birth weight in kilograms. So the n is now the numbers of babies we are expecting is 3,226. So now the mean of this kilogram or this weight will be 3.39 kg, and the standard deviation will be 0.55 kg. So now the normal distribution is completely described by the two parameters mu and sigma, where mu represents the population mean or center of the distribution, and sigma the population standard deviation. It is symmetrically distributed around the mean. Population with the small values of the standard deviation sigma have a distributions concentrated close to the center mu. Those with large standard deviation have a distribution widely spread along the measurement axis. Now, one mathematical property of the normal distribution is the distribution lies between mu minus 1.96 x sigma plus and mu plus 1.96 x sigma. Okay, so this is the graph on the right side, top left right corner. Now changing the multiplier of 1.96. Now what is the 1.96? It is the standard deviation of the mean to 2.58. Exactly 99% of the normal distribution lies in the corresponding interval. Now in practice, the two parameters of the normal distribution mu and sigma must be estimated from the sample data. For this purpose, a random sample from the population is first taken. The sample mean x and the sample standard deviation SD x is equal to s are then calculated. If a sample is taken from such a normal distribution and provided, then a sample is not too small, then approximately 95% of the sample will lie within this interval. This is the given interval, and this is the mathematical representation. And there's an example of the range of sample out of babies, which I have discussed about before. Now you can see the formula used, and the answer will be there. Now, what is elementary probability theory? So a probability gives the likelihood that a defined event will occur. If a defined event will occur, then the probability, it is quantified as a positive number between 0. The event is impossible. If the positive number is 0, the event is impossible, and 1, it is certain. Thus the higher the probability of a given event, the more it will be occurring. So as we know, the probability, I'll be telling you it in simple meaning. So for the simple meaning, if the probability is low, then the event will occurring will be impossible or very very low. So as the probability increases, the chances of the event occurring will also increase. So if for example, if A is an defined event, then the probability of A occurring is expressed as P of A. So and it can be expressed in a number of ways. So if request a frequentist approach is to observe a number of particular events out of a total number of events. Thus, we might say the probability of a boy is 0.52 because out of a large number of singleton birth, we observe that the 5 to 52% are boys. Now, what is a model based approach? A model based approach is where a model or mechanism determines the event. Thus, the probability of a 1 from an unbiased die is 1.6 since there are 6 possibilities. So when you throw a die, there are 6 possibilities, like it can come out from 1 to 6, any number from 1 to 6. So each equally likely and all adding to 1. So the probability of occurring number 1 is 1 by 6, and similarly for 2 and 3 till 6. Okay, so now let us see what is opinion based approach. An opinion based approach is where we use a past experience to predict a future event. Now we don't know what will be the we don't know anything, but we have a past research about this, past experience about this, so we will make an opinion for the future event. So we might give the probability of our favorite football team winning the match. For example, in test matches in England, so there was very heavy rain. So from past experience, from if for example we have a test series of 5, and we learned that in first three test matches it rained in England. So on the fourth match, I can give a opinion based approach that yes, it will rain today also. So this is an opinion based approach. So this is an example of opinion based approach, and this is the end of elementary probability theory for now. And thanks to you all for listening till the end, and bye bye.